1.9 billion servings of Coke are consumed daily worldwide. But how is it actually made?
Clear.
Acknowledged. Proceed.
Let's start with step number 1, water.
Water enters the sand filter tank, passing through layers of fine sand and gravel. Coarse impurities and dust are
The next tank is the carbon filter. This step is crucial so the water has no taste of its own, removing chlorine and odor.
Water for Coke must be neutral, meaning it has absolutely no taste.
Before moving into the pipes, water passes through a chamber with blue UV lights. The UV rays destroy the DNA.
Mixing the concentrate, workers open these drums. An extremely thick, dark brown/black liquid pours out.
caramel addition. If caramel isn't in the concentrate, caramel E150D is added separately.
The addition of phosphoric acid and caffeine. These elements give Coke its distinct bite and acidity felt on the tongue.
The final syrup is rapidly heated and then immediately cooled. This process ensures no bacteria survive in the syrup.
The finished final syrup is now stored in chilled tanks. Digital meters on these tanks display temperature and volume.
The proportioner machine, the heart of the factory. The standard ratio is typically 5 parts water to 1 part syrup.
The liquid must be chilled before carbonation. The liquid temperature is brought down to between 2 and 4 degrees Celsius.
CO2 molecules are trapped between water molecules. As they cluster, they form bubbles. This process is what makes the drink fizzy and bubbly.
H's. The preforms pass through a tunnel lined with bright orange infrared lamps on both sides. These lamps soften the hot preform enters a mold. A rod stretches it down and high-pressure air inflates it or thins.
Mold cooling. Cold water circulates inside the mold to instantly cool and harden the hot plastic.
Before filling, bottles are flipped upside down and blasted with ionized air. This removes static electricity and blows out any potential dust particles.
High-speed cameras take photos of every empty bottle. If a bottle is misshapen or has a hole, the machine instantly rejects it. Show how the machine grabs the bottle by the neck ring, not from the bottom. This keeps the bottle stable regardless of how fast the machine spins. The nozzle locks onto the bottle. First, CO2 is purged into the bottle to remove oxygen and equalize pressure. Then, the liquid enters.
The swirl effect. The liquid doesn't just dump into the bottle, it swirls down the sides. This technique prevents foam from building up.
.59 torque application. Capping heads spin down and tighten the cap onto the bottle. The machine ensures the cap is neither too tight nor too loose. If any syrup spilled on the outside of the filled bottles, they pass through a water shower to wash it off, so the bottle isn't sticky. A secondary camera verifies the printed date code's legibility. This step is crucial for complete traceability. Multi-packing. Bottles are grouped into sets of 6 or 12. A plastic sheet is wrapped around the group.
Interlocking pattern. The robot doesn't stack boxes in straight columns, but in a crisscross pattern to ensure the stack doesn't topple over.
Once the pallet is full, a machine wraps a thick layer of transparent plastic around it to secure the load for transportation. In some modern factories, robots store the pallets in high warehouse racks without human help. This looks very futuristic.
This is the effluent treatment plant. Wastewater, like that from washing, is thoroughly cleaned here before it is safely returned to the environment.
The health of these rainbow trout is the clearest indicator that the water discharged from the ETP is completely clean. This process converts the used plastic into clean flakes, or rPET, which can be extruded and molded into new bottles.
This was the story of a simple mixture of water and sugar that became a billion-dollar industry.